Stoichiometry, such a big word, right? So, stoichiometry is nothing but it's actually been derived from two Greek words, stoichen, which means element, and metron means measure. So, to learn, so stoichiometry, in this concept, we will be studying about how we will use a chemical reaction or an equation to figure out the calculation of masses of reactants and products. Okay, but before all of that, before we start all of that, we need to understand the meaning of chemical equation, a balanced chemical reaction. Okay, so let's take an example of a reaction. H2O, H2 plus O2 gives rise to H2O. Okay, in this chemical reaction, you have the two reactants. The ones which are on the left side are called as reactants, and the ones which are on the right side of the arrow are called as products. Okay, and in this case, we just have one product. Okay, now in this reaction, you will notice on the left hand side, it has two atoms of hydrogen and two atoms of oxygen. Whereas on the right side, it has two atoms of hydrogen and only one atom of oxygen. Which means this particular reaction in this form is not following the law of conservation of mass, which states that matter can neither be created nor destroyed. Okay, so according to this law, you need to have the mass on the reactant side should be equal to the mass on the product side. Okay, that's all. So the balanced chemical equation will have equal amount of mass on the reactant and the product. Okay, so that's the main reason we need a balanced chemical equation. Not only that, let's take another example. I will get back to this. CH4 plus, that is methane, reacts with oxygen to give rise to carbon dioxide and water. So our reactants are CH4, that is methane, and oxygen, whereas the products are carbon dioxide and water. Okay, now in this reaction, if you notice the previous one, I didn't put anything in brackets. So this will tell us the state of the particular substance. And to do that, you will have gaseous, which is G, which is gas. For solids, it's written as S. For liquids, it's L. And if suppose a salt, let's take sodium chloride, is dissolved in water. Okay, so this means that it is dissolved in water. So this is written as aqueous. Okay, so in a balanced chemical equation, you also have the state of a particular substance. Also, these arrows are very important. When we would have it as a forward arrow, it just means that this reaction is moving forward. But when you have a backward arrow, it will mean that it is reversible in nature. Also, you can write the conditions of temperature, pressure and all on top of the arrow. Okay, so this is a basic idea that I wanted to give you about a chemical equation. Now, it is very important for us to learn as to how to balance a chemical reaction. So let's start with that, and then we will understand what all of this has to do with stoichiometry. Okay, so first itself I told you so let me just put a heading on top perhaps. Or reaction. It's a very important topic. Okay, so the first itself I told you that for balancing a chemical equation, the reason we're doing that is because of law of conservation of mass. Okay, so there are various methods by which you can balance a chemical equation, but for some reason I've always found this particular method that I follow pretty easy. So let's take an equation and I think we'll go from there. Okay, first of all, I'd like to tell you one more important point is that when we balance a chemical equation, we start with all the elements except for hydrogen and oxygen. So we generally don't start with hydrogen and oxygen because they're most commonly found in chemical reactions, and generally because of their high reactivity, sometimes they form more than one product. Okay, so that will lead a lot of confusion. So suppose you have H2O plus CH3 CH2OH. It's just an example. I'm not sure if there's a reaction with these two as products. I'm not sure about that. But the thing is, here you have two substances having the same atoms, that is hydrogen and oxygen, then you would not be able to clearly put as to where you have to, basically balance the chemical equation. So that's the only reason why we tend to balance the other elements first. So let's take a simple reaction. Okay, Fe, that is ion, of course ion is going to be a solid, reacts with oxygen, which is a gas, okay, to give rise to Fe2O3. Now this is also a solid. Okay, so now let's look at what are the elements present on the reactant side and the product side. So Fe and O. Then because Fe and O are the reactants over here, the two elements, this will also have Fe and O. Now the first step we need to do is let's write down the number of atoms of each element. So this has one atom, this has two atoms, this has two atoms, and this has three atoms of oxygen. Now, first rule is we are supposed to convert it in such a way that the other elements are being considered. So first we will multiply it with 2. So 1 into 2 equals to 2, which means I will be writing here as 2Fe. Now this shows that iron is balanced, but oxygen is not balanced. Now had it been a 4 over here, I could have just written it as 2 into 2. So I would have put another 2. 2 2s are 4. So 4 4 balanced. But 2 and 3, 3 is not a multiple of 2. So the only thing we can do is multiply them with each other. So I will be multiplying 2 with 3 and over here 3 with a 2. Which means here I will add on this 3 to the reactant side. Okay, and I will be adding this 2 to the product side. Which means the number of oxygen atoms is changing to 6. But the issue right now is that 2 into 2 equals to 4. So the number of atoms for iron will change to 4. Or if you haven't understood this, so then I'll again multiply 2 into 2 equals 4 and this becomes 4Fe. If you want, I will do it step by step. Let's do it again. It's alright. Fe plus O2 gives rise to Fe2O3. First step I'm doing is I'm changing. First we'll be writing it down. Oxygen 2, oxygen is 3. Now I am multiplying this ion with 2 to give us 2, which means this is multiplied by 2 and this ion is getting balanced. Next the oxygen has to be balanced. So we get 2Fe plus O2 gives rise to Fe2O3, which means ion is 2 right now. Ion is 2, it's balanced. Oxygen is 2 and oxygen is over here, it's 3. So the only way we can make sure this is equal to this is if we multiply it with each other. Because if it had been 4, assume if we had Fe2O4, okay, I could have just multiplied this 2 with another 2 to give us this value. But that's not the case. You have 3 over here, which means it has to be multiplied with each other. So into 3 into 2. So this 3 will come over here. Okay, so and this will give us 6 and 6. You have 6 atoms of oxygen. Now this means Fe, 2Fe plus 3O2 gives rise to 2Fe2O3. Okay, now here if you notice, Fe is 2, oxygen is 3. Sorry, 3 into 2, that's 6. Basically, when you have it like this, you have to multiply this number with this one. Okay, so that's why we're saying it has 6. 6 atoms of oxygen. Whereas iron is 2 into 2 over here, because this number gets multiplied with this as well. It's 4, and 2 into 3 equals to 6. So this shows that iron is not balanced. So we will multiply this with another 2 to give us 4. Okay, and then this will be changed to give us 4. Okay, remember when we balance a chemical equation, suppose you have O2, you cannot write O3. Okay, fine, we'll write it 3. No, this is wrong. If you have O2, the only change you can do is on the left side of that particular substance. No matter what, you cannot modify the right side. You can only modify the left side of that substance. You will start with balancing the other elements out, and then in the last you will come and balance the oxygen. And usually you have various methods called the hit and trial and the step by step, but for some reason I found this the easiest, but you are free to check out any other method that you find comfortable. Okay, personally I find this one the easiest. You just put down the elements and then balance them out, and it might look a little long, but it gives us it basically makes it easier for us to figure out the answer or the balance equation. Now here it follows the law of conservation of mass, because the number of elements or the mass of the reactants will be equal to the mass of the products. Let's do another equation. Mg solid plus O2, which is going to be a gas, gives rise to MgO. This is a solid. Now this is a reaction. I'm sure you would have seen burning of magnesium ribbon in your classes, and this is the reaction for the same. So when you have this particular equation, let's first step we are going to be doing is writing out the elements. Now, 1, because only 1, and this is also 1. This is having 2, this is having 1, which means the oxygen atom has to be balanced. Now, the only way I can, okay, so now what we will do, we will write MgO2. Do you think this is right? This will be wrong, because this is, again, I'm sure you would have learned this in your class 9. It's about crisscross, class 9 or 10. You would have studied about crisscross method, right? So Mg has a valency of +2, oxygen has -2, these two get cancelled, MgO. So you can't write MgO2 and balance out the equation. It's wrong, I told you. Okay, so what we will be doing is, we will have to multiply this with 2. So 1 into 2 equals 2, which means here you will have 2 MgO. So Mg plus O2 gives rise. I mean, for simplicity, I'm not writing the individual states, but you should, I mean, it's better that you do. But right now, let's focus on the elements. Okay, so here you have magnesium has 1. Here magnesium, however, has 2 atoms, because 2 is applicable to the magnesium as well. And this oxygen is balanced. So no issues. So this is done. Right. So how do you convert this to this? You just multiply it by 2, which means you have to write it as 2. So here you have 2 atoms of magnesium, 2 atoms of oxygen. 2 atoms of magnesium and 2 atoms of oxygen. Notice I did not make a change on the right side. I only made a change on the left side of the particular substance. Let's do another equation if you've still not cleared up, or if it help you understand things better. C3H8 is gaseous plus oxygen, so it's getting burnt, to give rise to CO2, which is a gas, plus H2O, which is going to be a liquid. Now, the first thing we will do is write down the elements: carbon, hydrogen and oxygen. So, C3H8, 8 atoms, oxygen 2 atoms. C, 1 atom, oxygen 2 plus 1, 3 atoms, hydrogen 2 atoms. Now notice your oxygen, there are two compounds which have oxygen in it. Now this will mean that it might lead to a certain amount of confusion when you balance a chemical equation, which is exactly why we do it in the end. So let's start with carbon, or I'd rather do this one second. Okay, so let's start with carbon. So we have to convert carbon to 3. So we will multiply this into 3, which means that it becomes 3CO2. So C3H8 plus O2 will give rise to 3CO2 plus H2O. Okay, so C3H8, carbon number of atoms is 3, hydrogen is 8, oxygen is 2. There has not been a change in the reactants. In the products, carbon has changed to 3, hydrogen has changed, no, there's no change. Oxygen, you tell me, do you think there is a change? Yes, there is, because 3 into 2 equals to 6, 6 plus 1 equals to 7. So when I put a 3 over here, this also meant that this value became 2 into 3 plus 1, that equals to 6. Sorry, that's equal to 7. Okay, now here if you notice, carbon, oxygen, there is a huge difference. But let's finish up with hydrogen, because you have to balance. Oxygen is again there in 2 compounds, but hydrogen is only in one of these. So this has to be changed. We know that for sure. So here you have an 8, and here you have a 2. 2 into 4 equals to 8, which means here you're adding a 4 in front of water. Now this also means that it will affect the oxygen. So the oxygen's value will change to 4 ones are 4, 3 twos are 6, 6 plus 4 equals to 10. So oxygen's value is becoming equal to 10. So you have 10 atoms of oxygen. So C3H8 plus O2 gives rise to 3CO2 plus 4H2O. And C is 3, hydrogen is 8, oxygen is 2. Here you have carbon is 3, hydrogen is 8 and oxygen is 10. Now you know what you need to do. 2 into 5 equals to 10, which means here we will multiply it by 5, and there you have a balanced chemical equation. One thing I'd like to point out here is, had we tried balancing oxygen in the previous step, that is when it was 7 and 2, we wouldn't have been able to figure out where exactly we have to multiply. We wouldn't have been able to understand if we had to change it here, and if we changed it here, the carbon would have changed. Right. So to avoid all of that confusion, we started with balancing the hydrogen, the hydrogen first, because hydrogen is present in only one of these compounds. Okay, and then we did the oxygen. So for balancing the chemical equation, it has to, the reason we do that is because it has to follow the law of conservation of mass. And we started with writing down the elements along with their individual numbers and then balancing them one after the other. This is the method that I follow. You can feel free to, go ahead and try and figure out whichever is easiest for you. And the only way you'll be able to balance chemical equations is if you practice a lot more than like 3 equations. You need to do more, and only if you practice it, you will be able to do it well. The reason we talk about why balancing chemical equations over here is because it's going to be playing an important role in stoichiometry and stoichiometric calculations, which is going to be the next video.